The BO project has as its main goal the creation of hybrid magnetic nanoparticles coated with a lipid membrane taken from an extracellular vesicle. But what are extracellular vesicle, EV, nanoparticles, and why are they so important? EVs are particles produced and released by tissue cells, such as those in your body or in single-cell organisms. EVs are extremely small. Their size varies from 30 nanometers to 1 micron. Comparatively, they are 1,000 times thinner than a human hair. EVs were discovered in the mid-20th century, and at the time they were thought to be a way for cells to dispose of some of their waste matter. However, during the first decade of the 21st century, scientists realized that EVs are able to carry lipids, proteins, and nucleic acids, and that they can transfer such material between two cells, making them key players in intercellular and interorganism communication during physiological processes. This means that EVs are capable of carrying any message from one cell to another, making them critical also in the onset and spread of certain diseases, including cancer, Alzheimer's disease, and infections. Significantly, EVs could be used to deliver therapeutic medicines into cells. This special ability and the innate navigational performance of EVs is made possible by the unique structure and composition of their membrane, which so far has not been possible to replicate using synthetic materials. BO will reconfigure and utilize extracellular vesicles to naturally tailor the biological identity of synthetic nanodevices and nanomaterials. The hybrid nanomaterial envisioned by BO is made up of a core of magnetic nanoparticles camouflaged by an EV membrane that will attain key biomimetic functions, including evasion of the immune system and organ and tumor targeting. The fact that the EVs have biological functions implies that EVs could be used as a transport vehicle to deliver certain medicines targeting specific illnesses, and can do so without triggering an immune reaction, because the body will detect them as friends. The implementation of BO will be conducted in 3 sequential steps: the fabrication and configuration of the nanomaterials, the dressing of the synthetic nanomaterials with an EV membrane, and a biological performance testing. The project is funded by the PhET Proactive Programme, and it brings together a robust and complementary team which includes 11 partners from 7 European countries. This disruptive project will be one of the first examples of biogenic nanotechnology. It will contribute to the development of biogenic interfaces for cell and organoid-on-a-chip interaction, and will impact future studies on biogenic nanotechnology, which are crucial for addressing global issues such as water pollution and decontamination, antibiotic resistance, non-communicable diseases, and food safety. If successful, this technology will foster progress in the creation of implantable nanodevices and nanomaterials, leading to sustainable production, contributing to maintaining and strengthening the leadership role of European biotechnology, and by improving the quality of people's lives. BO, biogenic organotropic wetsuits.